All right, we're going to talk about our last topic in Unit 1, which actually covers two different subtopics. They are casting and variable ranges. So, right now, what we've just been talking about was, what happens whenever we have two variables or two numbers or whatever they are, and we're adding and subtracting them, and then what happens if they're, different types and how do they mix. So what we are going to do is kind of figure out a way that we can actually mess with that ourselves a little bit, and that process is called casting. So we're going to make a new file. We'll call this casting.java public class casting. It would make a lot of sense if I knew I was going to make this video if I actually made this ahead of time, but here we are. So here's what I'm going to do. So just like we were talking about last time, I can create a variable. Actually, let's do this. Just to remind ourselves. So if I make a new double, so the variable is going to be a double, and I call it x. If I take 12 divided by 5, all right, so remind yourself really quick what this is going to print out. So let's go ahead and try that. Let me open up, save. All right. So when I go to run this, casting.java, what will happen is that I get 2.0, which is not intuitive to us when it comes to a mathematics standpoint. But if we think about what's going on here, I take a step back. The other thing that might throw us off is the fact that we think this is a double, so everything should work out just fine. But it doesn't, because what's happening over here on the right-hand side is 12 is an integer value. 5 is an integer value. They're actually both integer literals, is what we probably should call them technically. And so when I divide these two, I'm using this integer division. So 12 divided by 5 in integer division, it gives me 2. And then I truncate, I cut off the rest of, whatever that would be to the right of the decimal place, which in this case would be, of course, 4. And so what it seems like, I'm rounding essentially to just 2. Even though I'm storing in a double, this will get turned into, or actually integer division will occur, and then I will turn it into a double afterwards. And that's why I get the 2.0. So let's say, though, I've got some variables. Maybe they're integers, but I want to turn them into doubles and actually do that type of calculation with them. And so there's a phrase for this, is called casting. So we have a new operator here. It's not going to look like an operator, but it is an operator. It's called the casting operator, and what it looks like is this. So this is my casting operator. In this case, what I'm going to be doing is I'm going to cast to a double this 12. And let's see how it changes things. So if I go and I run this again, now I get 2.4. All right, so here's what happened. This double casting operator, what it does is it casts 12 to a double first. Once it turns 12 into a double, so it's 12.0, and then I divide it by 5, which is an integer, I will use floating point division, because one of the numbers is a floating point, it's a double. I just casted that, and so that's the type of division that it'll use for me here. So what I can use is I can use this casting operator whenever I want to, in an operation, to change what type of arithmetic is being done, or I guess that's not arithmetic, but what type of operation is being used, whether it's an integer or a floating point division operation. I can change it using this, but I can also cast other ways as well, of course. So for example, let's say, now the one thing that always throws me off a little bit whenever I am using these things to cast is the parentheses, and so sometimes I like to be overly cautious to make sure I'm doing things correctly. So let's say I've got the number 2.4, and then I want to divide that by 1.2, but I'm going to cast them. Now, intuitively, you might think, well, wait a second. Last time that we were trying to store like double values inside of integers, it didn't go so well. Java didn't like it because we were potentially losing some precision, and it wasn't a fan. And so you might think that this isn't going to work out the way we want it to. But I guess it didn't actually tell me anything because it's going to be the same thing either way. Here, let me change this. Now I've lost my train of thought. Whenever I'm casting, I can cast something to an integer. That is fine, even though I'm losing some precision. So Java didn't like it before because it kind of assumed that, like, hey, he doesn't know what he's doing. Let's warn him. Versus now you've actually used the casting operator. It's going to make the assumption that, okay, he must actually mean to do that. So, all right, let's see what happened here. So I had to change the problem because whether 2.4 divided by 1.2 or it was 2 divided by 1, it was going to give me the same result either way, which was uninteresting, so I changed it. And so what we'll notice happened here is I casted both the 2.4 and the 1.3 to integers first. So that got cast to a 2 and then to a 1, and 2 divided by 1 is 2, of course. But I'm storing it in a double, and so I get 2.0 back. All right, so this is what my casting operator does. One thing that we might want to discuss is what actually is being happened here, because rounding is not the correct word. It is the doubles when they get cast to integers. Rounding is not the correct word that's being done here, because it will always round down. And so really truncating is the better word for it. And so, but what if I actually want to do some rounding? How can I do that? And so let's kind of be a little bit clever. So let's say I want to do something like this. So if I took 14.0 and I divide it by 5.0, what I would get, but I want to store this as an integer, what I would get is 2.8. And if I try to store this as an integer right now, I get an error. Actually, let's confirm that real quick. An error. All right, I got an error because I am trying to do double division and get a double, but then I'm trying to store it in an integer. And Java thinks that I'm doing something wrong here. So what if what I really want to have happen is I want to take 14 divided by 5. I want it to be rounded appropriately. Well, if I cast these to integers, first, so that's now cast. This is now cast. All right. What's going to happen? Did I save it? I think I did. Is I'm going to get 2. It did not round it correctly. It truncated. Well, it did what it was supposed to do. It didn't do what we wanted it to, though. It didn't round appropriately. It truncated again. So maybe if I instead of truncating or casting first, maybe I let it do the division. I guess I should have left that. I let it do the division and then cast afterwards. And what we're going to find out is actually that's not going to work either, because it's going to be the same issue where I'm going to get 2.8 and it's just going to get truncated one more time. So how can we come up with a foolproof way of doing this? So we can be a little bit clever here. So if ever I have two numbers, I want to divide them, I want to round them appropriately. The clever thing that I can do is I can add to them 0.5. All right, so why is this going to work the way that we want it to? Well, so if we think about this for a second, if we get numbers, write them down here. So if we get numbers, dividing things by 5. So let's say, I get 2. that's 1, 2.0, or I get 2.2, or I get 2.4, or I get 2.6, or 2.8, or I'm back to 3, and it's basically the same thing again. So if I were to add 0.5 to all of these, what I would get instead, I'll just put it out here. So I'd get 2.5 if I added that. Stop it. I would get 2.7 here. I would get 2.9 here, and I would get 3.1 here, and then 3.3. And so if I add 0.5 to all of these, what happens once they get truncated? Well, 2 doesn't change. 2.5 still gets truncated to 2, so that checks out. 2.2 was 2.7, still gets truncated, still 2. 2.4 to 2.9 still gets truncated, which they all should have been rounded down anyway. But anything that's 2.5 or greater, when I add 0.5 to it, it'll actually get bumped up like an integer value. It'll get bumped up to 3.1 and 3.3 for the 2.8. And so by doing that, by adding 0.5 to whatever is the outcome of this division here, it'll make it so that when I do truncate, it'll actually round it appropriately. So it's kind of a clever little trick that we can use to round appropriately. So when I go, I should delete these things. So when I go to run this, save. When I go to run this, then I get what I want. I get it actually rounded the correct way. So taking two doubles, so one of them has to be a double for this to work out, because if it's integer division that gets done anyway, it's going to truncate before I even add the 0.5. But if I have a double or two doubles, I'm doing some division with them. If I add 0.5, I'll then get rounded appropriately, which begs the question of, does this always work? And there's one specific example that it might not work for that we should think about. When would this not work out the way we want it to? And the answer is negative numbers. So let's go ahead and get rid of that for a second, and let's ask the question, because I don't think we've actually done it. If I have the number negative 3.4, and I, so what should I do here? I'm going to cast this. And I cast this to an integer. Does it get truncated again? Is it negative 3? Or does it get rounded down? Because rounding down in terms of negative numbers would actually be rounding down to negative 4. So what actually happens here? We should probably test this just to make sure we know what's going on. And the answer is it gets truncated. So in fact, not only does it not round, we can't even say that it rounds down correctly. There's no rounding that's going on, I guess, is kind of the important thing. Truncation is probably the best word for this. And so it cuts off all these other digits, and so negative 3.4 gets turned into negative 0.3, or negative 3. So how do I deal with this? Well, so this is kind of where our clever little trick fails. The 0.5 doesn't work anymore. I would have to instead, if I know it's a negative number, so if I know it's a negative number, shouldn't probably do that twice, like so, I would actually have to subtract 0.5. So that's one of the limitations of this nice little trick here, is the fact that I have to know if the number is going to be negative or positive, which, to be fair, I could test. That's a math thing. It's in the math class, which we haven't learned about yet. And so it's definitely something I could do. But yeah, that's where my clever little trick fails. I guess if I'm using the math class, there's a whole bunch of other functions I'd have available to me to round whatever, so it doesn't matter. But yeah, this only works if I know if the number is going to be positive or negative. So there's some limitations there. That's okay. All right, so that is everything to do with casting. There's one more thing that we're going to tack on here real quick, as long as we're talking about different primitive types, and that would be the max and min values of my different value, or my different primitive types, and then what happens with overflow. So what we're going to do real quick here is go and look at, that's not what I wanted, this was what I wanted. I brought this up a couple videos ago, I think, to talk about primitive types, and so I want to go ahead and look at this table again. Nice little table we got here that has all different primitive types in Java. And what we see is, of course, there's other ones than what we are, focusing on in computer science A. There are things like, bytes and shorts, and the one that I'm going to focus on here is what's called a long. And so there's a couple of different things that we're going to notice about this. So if I were to create a new variable called a long, I'm probably getting myself or ahead of myself a little bit. That's okay. If I were to make a new variable that's of type long, I would obviously use long instead of int. But then there's another thing you'll notice here that I have to use this little L to go along with it. And the reason for that is because if I don't, Java's going to think I'm using an integer. It's an integer literal, right? And so I have to be specific that the literal that I'm now working with is a long. The reason I want to use long is we can see here, well, so spoiler, these are my max and min values for what an integer can be. All right, from negative, what is this, 1,000 billions. So negative 2 billion something to positive 2 billion something is the only range of what I can hold here, which, in most situations is pretty good. Longs, on the other hand, are 1,000, million, billion, trillion, quadrillion, quintillion. Really, really large numbers, which is great. Good for them. So the question is, what happens when I end up adding numbers that are too big? Let us go back and see. So let's go ahead and make my integer here. So I've already forgotten what that max value was. I can get it, though. So there is actually something called the integer class. It's a wrapper class, of which we'll spend a whole bunch of time talking about wrapper classes later. But just suffice it to say that this class, of which we haven't really learned about classes either, stores a bunch of information about integers. One of the things that it stores is a constant value for what the max value for an integer is. So if I use this, I can figure out, it can tell me what exactly it is, and the answer is, well, what we just looked up, about 2 billion? About 2 billion. So what happens if, well, let's do this first. Let's make another one. I'm going to try and store something bigger than 2 billion. Let's store 3 billion. So 3, that's 1,000, that's 1,000,000, and that's 1 billion. All right. So let's try to store about 3 billion into an integer value. If I do that, what will happen is error. Tells me it's too large. Java knows, hey, you screwed up. You tried to store something too big into this integer value. Please try again. So I won't do that. I won't do that. I don't want to do that. I'm going to do this instead, though, because why should I be able to do this? What if I take my max value and I add, I don't know, 10,000 to it. 10,000 to it. And then I print it out. All right. So you would think that Java's going to give me an error again here. And you'd be wrong for some reason. So Java doesn't like it when I straight up try to put an integer that's too big or too small into it. However, if I do some arithmetic and get a number that's too big, it lets me do it. No big deal. But you'll notice here what I get is this negative number. So I took something that was the size of about 2 billion, added 10,000 to it, and now I'm at like negative 2 billion. So what happened? Well, the answer, if you remember back from your computer science principles days, this is what's called overflow. So, the integers are only meant to store values up to, roughly 2 billion something. And so what happens is when I try to store more than that, the actual issue, and this isn't exactly how it works, but it's roughly how it works, is good enough for us right now, is that there is a bit at the beginning of my integer values that decides whether or not the number is going to be negative. Again, that's not exactly how it works, but it's good enough for us right now. So it decides whether or not the value is negative. And so if I try to increase my, what was in my variable by, in this case, 10,000, or if I just try to increase it by 1, then all those bits would flip, and it would cause that very first bit to flip, so the one all the way to the left to flip as well, which then, Java thinks that variable is now negative. So this is an example of overflow. Anything that goes outside of that range is no good, and is not going to mean what we want it to anymore. So the question is, how do we actually store these values? Now, the interesting thing is everything I've told you up to now is totally within the curriculum for Computer Science A. This next thing is not. So they tell you what the problem is, but not how we can go about fixing it. The answer, of course, is longs, creating long variables. So let us go ahead and take a look at this. So what if I instead try to make a long variable like this? All right, so this should hopefully fix our problems. It's not going to, but it'd be nice if it did. Let's go look and see what happens. So if I go and print this out now, so what you'll notice, all I did was here is I said, okay, y is going to be of type long. So much more room in there for me to store things. So what I'm going to do is compile this and then run it, and I get the same thing again. How could that possibly be? I changed it to be a long. Should be able to store more information. Well, here's my issue. So what we were talking about is the fact that whenever I'm working with, where did this go? There it is. Whenever I'm working with longs, I need this L, this uppercase L, to differentiate between integer literals and long literals. So what's happening currently is that what Java thinks it wants me to do is take an integer, which was the max integer value, add to it, okay, 1,000 or 10,000 is an integer value. If I add those two together, what I'm going to be using is integer addition, and thus we'll get returned another integer. And so now that value will be negative, 2 billion something. And then it gets cast to be a long. So what I have to do first is change this to be long addition, not integer addition, and that's pretty easy. I just need to let it know that 10,000 is a literal long value. And so if I go ahead and save this, and I go and I try to compile again, it'll do the addition that I wanted it to. The great thing here is that I can use long values to help me out and to store numbers that are too large. I mean, so there will come a point, of course, where I will run out of space here as well. It's just that it's going to take a really long time. And so there will come a point where I can't really help myself using things that are like inherent in Java. There are other classes you can get that have much larger variables or much larger variable types in them if you really want to. But as of right now, for what is native to Java, this is all I've got. I can get longs, which is plenty in most cases. One side thing that I probably should have mentioned before is worth noting. I don't know, it's called a. There is of course an integer min value as well. So yeah, so we talked about casting and all the good things that go along with that, and now we've talked about potential issues with overflow. But then we also figured out how we can fix that by talking about these long values. Again, the long values are not within the scope of the Computer Science A exam. However, I feel like it's worth knowing. It'll be useful to you. So that wraps up everything in Unit 1. And so the great thing is that the next time you watch one of these videos, what I will be talking about is not, hey, there's these things called classes that we don't know about. We'll be talking about classes, and that'll be a good time.